Okay. Sorry, Whitney. I forgot to record right at the start. But here we go. So when we take the limit as x approaches -1 and we stick it straight in, we get the square root of 16, which is 4. Stick 3 into the second problem. We get 0 on the bottom. So 4 over 0 does not exist. Now we're to trig. Okay? So we're looking at this. What's the limit as tangent of x as x approaches 0? So we grab out our unit circles. And so my unit circle is right here. So the tangent at 0. Tangent at 0. Remember, tangent is sine over cosine. So it's the 0 over 1, because it's y over x, because sine is y, x is cosine. 0 over 1. What's 0 divided by 1? 0. Thank you. So the tangent of 0 is 0. That's the limit as tangent approaches 0. If you want to know why, well, remember chapter 2 of Trig. Nobody remembers chapter 2 of Trig. Tangent, the graph of tangent had asymptotes, and tangent looked like this.
Jada Price, please come to the office. Jada Price.
And so you can see from the graph that tangent as we approach 0 is 0. Okay? And then the next one would look like this, and so on.
Oh, I do remember that. I said all these cute little drawings.
Yeah. Okay. Okay, cosecant is the reciprocal of what function? Sine. Because anything with a its cofunction will not have a in front of it. So cosecant is sine, secant is cosine, tangent is cotangent. But then that makes sense. The with the not Okay, so cosecant is with sine, so it's the reciprocal of sine. So at pi over 4, what's the sine? Well, we go to our unit circle. Boom. At pi over 4, sine is the square root of 2 over 2. So cosecant is 2 over the square root of 2. Do the math gods like us when we do that? No. Why not? The math gods do not like square roots in the denominator, so we multiply top and bottom by the square root of 2. So it's 2 square root of 2 over 2. No, I am not the math god. So it's just plain simple square root of 2. Emerson, did you have a separate trig class, or was trig all in with algebra 2 for you, where you were at?
It was a separate trig class.
Okay, that's good. Okay, so that's plugging straight in, and now we get piecewise functions. So piecewise functions, you have to look where this is. Okay, where is -3? Does that fit into this one, or is it at the edge of both of them? Where does it fit on this one? The top one. So you just plug -3 into there, you get -6 plus 1, which is -5, you're done. Okay? Where's 6 on this one? Well, it's the edge, it's what's in between. So you have to solve both of them. So if you stick 6 in the top one, 6 over 3 minus 2 is 2 minus 2, which is 0. And then if you stick 6 into the next one, the cosine of 6 pi. Well, what's the cosine of 6 pi? Well, what's the cosine at pi? Or at 0 pi and 2 pi and 4 pi? Come on, it's on your unit circle. Cosine at 0. 1. Okay? This is 0. This is 1. What do we have? We have a conundrum. Does not exist. They go towards two different things. Okay? Okay. This says, find the limit as x approaches pi from the right. which one do we use? The cosine or the sine in this one? Why the sine? Because it's greater than or equal to sine. So we're approaching it from this direction, which is a sine. What's the sine of pi? 0, because it's the y value at pi. Okay, you guys remembering how to use your unit circles a little bit? Okay, so that's what we're doing today, is piecewise function and plugging directly into functions. So you'll have, this is an assignment, this is an assignment, this is an assignment, and this is an assignment. So you're kind of four assignments in there with all the videos. So yeah, you got plenty to do, plenty to keep you busy in the second half. Boom. Stop sharing.